is scary smart. So when he sent me this 140 character introduction, I wrote him back and said, do you really want to use words in your introduction that no one's going to know what they mean but you? So he sent it back, and now we have some things that we probably all understand. But he is into some fascinating stuff. So we're going to welcome next Phil Earnhardt, who's going to talk about finding the zone, chaos theory, and human performance. Phil is a reformed software engineer and studies the application of tensional integrity models to the human body. The bones, they float. That's how people say, the bones, they float. So he's about floating bones. And in fact, on Twitter, he's at floating bones. Please welcome Bill.
So we're talking about chaos theory tonight, but the big thing we're going to do is we're going to deal with any chaos anxiety you have. Then we'll get to talking about human performance. So one of the first scientists who really ever dealt with chaos theory was Sir Isaac Newton. Now, he was one of our greatest scientists of all time. He invented calculus, co-inventor, and he also did the 3 laws of motion. So Newton loved to think of the world as a clockwork kind of world, where everything worked precisely together. And it was a deterministic and a predictable world. Well, one of the things Newton dealt with was astronomy, planetary motion. And he got into a lot of trouble with that because things didn't exactly work as clockwork. So one of the things he worked with was the 3-body problem. That's about precisely predicting the movement of something like the Earth, the Moon, and the Sun. And this is a difficult problem in general because they're all pulling on each other and they all interact with each other. They tried to simplify the problem by having a very small mass in the middle that wouldn't pull a lot on the other two. This wound up being a really bad idea. And what happened was, when you look at the motion of the small object, it starts to be predictable, but over time it starts to be chaotic and unpredictable. Newton didn't like this. He never, ever published anything about this. And so basically that's the definition of chaos. It's deterministic with predictability limits. And that's all it is. So you don't have to worry about chaos. It's kind of like worrying about gravity or something like that. So what this means, we know it with weather systems very well. Because we can predict weather out to about 15 days maybe. But we can't go to 30 days. And we probably never, ever will be able to go out to 30 days. Edwin Lorenz was a professor at MIT. He's the first guy who ever published about chaos theory. And that was 250 years after Newton. Very long time. He's famous for the phrase the butterfly effect. And basically that means that a small change in a system can affect it over time. So that 30 days later, the flopping of a butterfly can have an impact. Doesn't mean that butterflies actually create storms. Bumblebees do that. So, prerequisite for chaos is nonlinearity. So, gravity is nonlinear, stuff in climate is nonlinear. We're also nonlinear. And you can test that for yourselves. Pull very gently on your earlobe. Do that now. And you can feel at first it's very fluid. But if you pull a little harder, it starts to get rigid. That's the green graph at the bottom there. Okay. Our bones are also, they work the same way. We're a loosely coupled structure. We don't work in a clockwork universe either. So Mr. Newton, if he ever thought about our bodies this way, was probably very upset about that too. And we have smooshability. So if you smush our bones, the geometry, the angles between them actually changes. And that's part of the source of our robustness. That makes us much less prone to injury. The gap between our bones is very important. So the other time we're tense is in a fight or flight reflex. So we instantly get very tense in our bodies. If you're on the African belt, someone's chasing after you, that's very important. But for us in our day-to-day living, it's not very important at all. One more example from astronomy is with the Apollo missions, we would sprint to the moon. We would blast up for 3 miles per second, turn around and blast in the other direction. Very energy expensive to do that. There's another way to get to the moon. It takes a little longer, but it only takes about 4% of the energy. You actually travel a very long path to the balance point between the Earth and the Sun. We'll call that surfing to the moon. And that's very similar to what happens into our bodies. Our systems actually deal with chaotic motion. And as long as we relax our bodies, we can get in these areas within the strange attractor called the zone. And that's what being in the zone is like. So the most important question to ask, how much tension do we need to do that with? Enough. And it's probably less than you think. Body-mind disciplines are great for discovering how much tension we need. Balance toys are very good to do that. The other resource a lot of us have is children. Watch children. They move with very little tension, and they also move in chaotic patterns. Very useful to watch them with that. Okay, so we covered a lot of material here. Oh, here's our homework. Stop worrying and embrace the chaos. Keep moving too. So I have slide notes available here. They're also available online. I'd love to hear any questions you have. Thank you very much.